Okay, question 8 gives us the equation y is equal to ax minus 1 over x squared minus 4. And it asks us to sketch this graph giving coordinates of points of intersection, stationary points, and equations of asymptotes. Okay, cool. So we're also told that a is strictly bigger than a half. Alright, so let's just go through. What about the axial intercepts? Should be a C, intercepts. So when x equals to 0, y is equal to a times 0 minus 1 over 0 squared minus 4, y is equal to a quarter. So there's an axial intercept at 0, 1 quarter. When y equals to 0, we get 0 equals to ax minus 1 over x squared minus 4, and that means that x is equal to 1 over a. Okay, so far so good. What about asymptotes? So we recognize that the denominator can be factorized into x plus 2, x minus 2 as difference of squares. So x equals to 2, x equals to minus 2 are definitely vertical asymptotes. We also have one horizontal asymptote. We recognize this is a proper fraction, a proper rational function. So y equals to 0 is going to be our horizontal asymptote. What about stationary points? So for stationary points, we ought to try differentiating this beast. What do we get? We get dy by dx is equal to a x squared minus 4 minus 2x a x minus 1 over x squared minus 4 squared. That top line simplifies to minus ax squared plus 2x minus ax squared, yep, minus 4a over x squared minus 4 squared. And if I want this to equal to 0, so I'm going to try for maxima and minima. So what am I going to get? I then want to get ax squared minus 2x plus 4a equal to 0. Sorry, that's just the same thing here, except multiplied through by minus 1. And so I want to know if, I want to solve this equation. In particular, though, I'm first going to look at b squared take 4ac. And what you'll find here is that this is 4 minus 4a 4a. That is 4 minus 16a squared. Now, this is 4 minus 16a squared is strictly less than 0 when a is bigger than a half. So because we know that a is bigger than a half, this a squared must be bigger than a quarter. And if this is bigger than a quarter, then 16 times a squared is going to be bigger than 4. So this whole thing is going to be negative. So we see, therefore, no turning points. Again, you may wonder, how did I know to look out for that? It's a little bit because I've got the answer in mind. I must admit I cheated somewhat. I actually tried drawing this graph with a equals to 1 first to see roughly what type of shape I'd get, and I noticed that there were no turning points. So although I've done all this working linearly, I had an answer in mind and I kind of knew there were going to be no turning points even before I started differentiating. So what does that mean our graph looks like? So again, please forgive me, this is not the easiest surface to draw on, but I'll try and get the main features down for you guys anyway. X. So we've got asymptotes at x equals to 2, x equals to minus 2, at y equals to 0. We've got a x-intercept at, a y-intercept at 0, 1/4, and we've got an x-intercept at what was it? It was 1/a0, and we know that this graph, what can I say about its sign? Well, because I know a is positive, when x is very, very large, everything's positive, that's fine. When x is very, very small, so very, very negative, this one is going to be positive still, but the top line will be negative, so the whole thing will be negative. So it goes negative, positive, negative, positive, I imagine. In fact, we can actually do a sign test if we like. In fact, we probably should. So if I look at my critical points, I've got minus 2, 1/a2. So something less than minus 2, the whole thing will be negative. Between here and here, I would get, so I've got y equals to ax minus 1 over x squared minus 2. X squared minus 2 would be negative, ax minus 1 would be negative, the whole thing would be positive. Between 1/a and 2, the whole thing would be negative, positive. So my graph is, again, I've looked at sort of what the answer should be, so I've got some idea. The graph should look something like this. Now, you'll notice that is not particularly well drawn. So I wanted to let you guys see what this could actually look like. So this is maybe what it looks like where a equals to 1, and this is the one I was telling you about that I'd seen earlier. But you see, there's actually an interesting question that asks, why is there this restriction on a? So says, take a note, there's a restriction on a. Why is this here? Well, it's because as long as a is bigger than a half, the general shape of the graph doesn't actually change all that much, you'll see. So that leads us to naturally wonder, what happens if I actually broke that restriction? What happens if I choose an a, say, smaller than a half but still positive? So look at what happens to this graph as I go from a half, or exactly equal to a half, sorry, something again very interesting happens. Sorry, it's a bit too sensitive here. I actually have one of my asymptotes cut off. And that's because I've got a repeated root on the top line. I would have a half x minus 1, which is the same thing as a half x minus 2, and so the x minus 2 is a repeated factor on the top and bottom. So that factor would disappear, and I'll be left with a regular rectangular hyperbola. Then in between positive and negative a half, I get another shape. This one actually has a turning point now. Same thing happens as I head towards negative a half. I have a repeated root on the top line and the bottom line, where in this case x plus 2 will cancel out, and then as I go even further, the shape of the graph sort of becomes a mirror image of what I had originally. So that's the reason why there's a restriction, is because for these differing values of a, I get different shapes for my graph.